My name's Eric Monti, Spider Lab Security Research. I'm a security researcher with Spider Labs Trustway, which is a fancy way of saying I don't have to deal with customers as much. So, all right. I'm here today to talk about some recent work I did, some projects related to the recent iPhone jailbreak and some reverse engineering around that. Kind of trying to see about exploring possibilities for weaponizing jailbreaks and rootkitting iPhones. So this is just kind of a quick overview, high level what we'll be talking about. I want to cover a little bit of jailbreak background for people who may not be that familiar with it. I mean, not everybody uses an iPhone yet. And then talk about kind of the processes that I used for reversing the jailbreak, and then later, as it turns out, there was a source released, and how I kind of incorporated that into the process. And I want to point out right off the bat, I'm not presenting any zero-day vulnerabilities. The exploit that I'm talking about was actually impressive, extremely impressive. I'm going to go on and on about how awesome it was several times throughout the talk. But it was actually the work of a guy named Comex. Anybody know? Who here has an iPhone? Can I just see some hands? All right, how many of you guys jailbreak your phone? Okay, cool. So not a whole lot of people, so I'll spend some time on the background. Anyway, so Comex, totally awesome. If you guys, you're familiar with his work, obviously. I was really intrigued by this, so which gets into my motivation for doing this. I'm actually relatively new with the iPhone. I've had it for about 2 years, and I started jailbreaking right away, but I just used it as a phone. And it took me a while to actually get into really looking at the underlying systems and so on. With this latest jailbreak, though, and I wasn't around for the libtiff vulnerability, which I'll cover later, but this was a remote client-side vulnerability in the web browser that was being used to let people install the jailbreaks on their phone. And it came out right around, their timing was really good, actually. They released it right around DEF CON, so they got everybody's interest right away. This whole security community started talking about it. And personally, I've been doing a lot of coding, working on product engineering projects. And, I kind of missed doing the vuln research. So when this came out, I got really interested. I have an iPhone, what's up with that? So a couple days after this came out, I guess I wasn't the only one in my company, because we had some of our pen testers come to our group and say, we'd really like to demo this vulnerability for some of our customers and, scare the crap out of them so we can sell them more stuff. So I'm like, well, okay, sure. I don't care what you do with it, but this is it's a great excuse for me to get into this. So I just jumped right in. All right, so agenda today, I'm going to do a little bit of background on iPhone, the architecture, the security architecture for the iPhone as well, which will bring us to the jailbreaking background, talk about just a little bit about past jailbreaks, and then move really quickly into just focus on the jailbreakme.com exploit by Comex. And then talk about the reverse engineering that I did early on, right after the exploit came out, and then turning that around and weaponizing it for, sort of simulated mayhem or malicious purposes. And then I'm going to have a demo at the end kind of showing the whole process that I ended up developing. All right, so a little bit of history. This last 4 years or so of iPhone existence has been kind of interesting, and I went back. This is not a complete, chronologue of all of the iPhone-related security issues and things that have happened. These are just the ones that really caught my attention. They're kind of related, I feel like, to the subject matter I'm talking about here. So back in 2007, I think it was early 2007, maybe mid, I don't know. There was a very similar vulnerability to what I'm talking about today in the libtiff library. It was exploitable through the browser. It was client-side, and there was a jailbreak released around this, very similar to jailbreakme.com star, actually. In fact, this was jailbreakme 1.0. And very soon thereafter, HD Moore and Metasploit guys, they got really interested in this vulnerability. The jailbreak team didn't find this vulnerability. It was found by Travis Morandi. But, it spurred a lot of interest in the iPhone right off the bat. So moving into 2008, 2009, things are moving along. Metasploit's getting really active by now. There's a whole lot of Metasploit modules that came out around the 2007, 2008 time frame. Also, we're starting to see malware popping up there, starting to really become, noticeable in the iPhone world. We've got several apps getting closed down by Apple. These are legit apps, that got passed through the Apple authorization process, which I'll talk a little bit about later. But they were found to be doing some sneaky things. They were gathering people's information, and they were deemed to be inappropriate, and they probably were. So a lot of these apps started getting pulled, happening in 2008, 2009, still happening now, but there's some very big cases right there. 2009, I don't know if anybody saw Charlie's SMS work. It was also really awesome. And here we are in 2010. We've got jailbreaking 2.0 at the end of the year. This whole time, there were a lot of jailbreaks from all the way through all versions of iOS. And I'm sorry, that's the iOS, not Cisco. That's Apple's own acronym. A lot of them dealt with the USB and tethering and that kind of thing. And I'll talk a little bit about them, but they weren't necessarily really tied to what I'm talking about today. In the meantime, this is my little story of my own iPhone saga. I was a very reluctant adopter. I got into the game very late, and it's only now that I'm really kind of really taking a really strong interest in it the last few months. Okay, so at a high level, iOS security. These are the things that are important to jailbreakers and also to an attacker. At several layers of the system, there are cryptographic signatures being validated. At the lowest level is the bootloader, and this is why you'll see a lot of the jailbreaks focusing on the bootloader, because that's probably the weakest link. You notice that there's nothing verifying the bootloader, and that's where their weak link is. But from there down, the bootloader verifies the firmware when it's loaded, when you boot up the system. The firmware verifies the kernel as it's loaded, and the kernel verifies applications that you've installed on the phone and that have come with the phone to ensure that they came from the App Store. And the common thread with all these signatures is that Apple is controlling what you can run on there all the way up the stack, or trying to, by making sure that they're the only approved signer. Sorry. So, it's actually not a bad design, and they actually hired some pretty smart people to develop it from our community. And Nate Lawson, I believe, did some work on this. He's a very sharp guy. So, all right, so from the architectural standpoint, these are just kind of the more technical aspects of this. And before I get back to the security model, the architecture is ARM. The actual hardware, the processor varies between models. But the big things to note is that older phones and older iDevices, or these iDevices including iPhones, iPods, iPod Touches, that is, and the iPad now. These all fall into the same family. They're all very similar, and the Comex exploit worked across all of them, across multiple versions, which is, again, was why it was very impressive. But anyway, so they may run ARM 6 or 7, and the distinguishing factor there is that the newer models use thumb instructions, which we'll talk about later. It just kind of gets a little bit in your way as you're doing some of the work that was involved here. The kernel's XNU based. It's like Darwin light. It's like OS X. It was designed with a lot of the common code. There are some major differences, but having that common frame of reference is really helpful when you're looking into and reverse engineering or writing code for the platform. So separate from the core processor, the applications processor is the baseband modem. This is where unlocks are focused, unlocking carrier. That's kind of, I look at it this way, is that the app processor is kind of controlled by Apple. The baseband modem is controlled by the carriers, and they made sure to keep it separate as much as possible. There have been flaws there, and they're commonly exploited. We're not really that focused on it, at least my research hasn't really been in that area yet. So I wanted to touch on it. It's also an ARM processor. And newer models have hardware layer encryption, which, again, I'm not that curious about yet, because we're not that interested in it yet, but there's been some interesting work done with forensics there. Okay. So the OS environment is very familiar in a lot of ways to anybody who's used Unix. You've got root partition and a user partition for the file system. You've got a root user and one regular non-root user, which is you, the user of your phone. All the apps you run as mobile. They've implemented, basically Darwin Unix security. And as I mentioned, the APIs in the system are based on Darwin as well. Okay, so here's where we get to the code signing. And this is kind of interesting from a sandboxing standpoint. And again, jailbreaks and rootkits are going to have to figure out a way to break out of this application security model. As I mentioned before, the apps have to be signed. The signatures are actually stored in the file headers of the actual executable inside of a .app that you download from the Apple iTunes store. And the actual check for the signatures is actually implemented in the kernel in execute. Like they actually check the signature is valid before they, you could think of it as branching to do this, but it's actually just in the hands execute. The sandbox itself, there's some other information. It's good to bear in mind. You're running as mobile if you're running any app from the UI. You may be interacting with systems that are running as root, which is where some vulnerabilities come in. And it's kind of a shrewd sandbox. And it's supposed to just restrict you to your own data, but in reality, it doesn't really do that. The reality is that Apple's authorization process makes sure that you're not doing anything you shouldn't. So the reality is, in fact, that the biggest security feature is Apple's app authorization. And they're not necessarily looking for security vulnerabilities. They're looking for propriety. They do restrict what you can do, but I haven't seen it yet, but I'm sure it's happened. People out there probably figuring out clever ways to get past their audits. And it's good to bear in mind that the signature occurs when an app is loaded. So once code is running in memory, our buffer overflows, our heap overflows, image overflows, any kind of code execution vulnerability is going to be fine. You're loading new code into memory, and the memory itself is not designed. All right, so that's the security model. The jailbreaks, their primary focus has always been to figure out new ways to break around these. Generally, you'll see one major dominant jailbreak per version of the iPhone OS. And once they have one working, Apple then starts working on a new version of iOS, and the cycle continues. So, as I mentioned earlier, like the two big remotes that, at least that I'm aware of, and the ones that got published and became those dominant exploits, were the libtip vulnerability and this new PDF vulnerability, which I'm going to talk in detail about. Usually, they tend to be USB-based. They tend to deal with bootloader or file transfer. They're interesting from a security standpoint, but they're obviously not as as wormable or as severe. And I want to mention, I've been consistently impressed by the quality of the work coming out of the jailbreak teams. I mean, these are really, really first-class applications that they distribute to jailbreak these phones. The last several, there was the Ponage tool, now this jailbreakme.com, and several others in between. They're just very, very impressive. So I just want to point out how impressed I am with the work there, and probably what kind of drew me into this, because these were obviously not only very talented hackers, but just very smart people working on this stuff. So I figured I'd get people to learn from. Anyway, so if you want to learn more information about this stuff, as I had known over the past few months, the internet's a good place, but you have to kind of filter through a lot of junk information, a lot of stupid blogs like that thing. Apple fanboys are kind of very vocal. So anyway, more about the jailbreak itself. Okay, so the jailbreakme.com. We kind of covered the past. I'm going to focus now just on this jailbreak, this latest jailbreak. So Comex was the author. Others were involved. They coordinated on developing this. It's actually called STAR. As I mentioned, everything's affected. Some older versions of iOS aren't, but those are kind of irrelevant because there are other ways to jailbreak them, including the libtip vulnerability. I mentioned it was released around DEF CON, and it came out right before the iPhone, or right after the iPhone 4G came out, and there were a lot of Apple users or iPhone users that were really waiting for it to come out. Another big thing to note is that it came out right after a crucial legal decision in the States. There was a fuzzy legal status on whether or not it was acceptable to actually jailbreak the phone, or whether you could be sued or put in jail for it. And they actually passed a law saying that it wasn't illegal, so there was no question about it anymore. And they actually coordinated their efforts with that process, waiting until that law had been passed. All right, so this is what the jailbreak looks like. Folks that have done jailbreaks and probably jailbroken lately using this won't be that unfamiliar, but this is what it looks like. You go to a website, you slide to jailbreak, and what happens is you download a PDF. And the PDF, you don't see this going on. It's actually in an iframe, hidden from you, the user, but it immediately begins executing code in your system. It exploits a vulnerability, which I'll go into detail about. And these prompts from here on out are actually code that's loaded into the payload of the vulnerability. So this is kind of the anatomy of this vulnerability, of this exploit, I'm sorry. So the star PDF exploit itself is a vulnerability in the CFF font display code for core graphics on the iPhone. There were actually several vulnerabilities that came out around the same time related to free type, and there's a lot of speculation that there might be some shared code. So it was an interesting vulnerability. We've seen a lot of PDF vulnerabilities in the last year, a couple of years actually. So it wasn't that surprising that this would be the source of this vulnerability, but it was an interesting bug nonetheless. The vulnerability itself is actually pretty simple. It's just a classic Stack Overflow, and it just overwrites EIP, or the ARM equivalent, PC. I'm going to have a complete brain freeze, so EIP we'll just say. The code runs as mobile. You're not root at this point. And the really cool thing is that they actually coupled it with another bug. There's a vulnerability in the a kernel extension called IOKit. It reads in a properties file, and there are integer overflow vulnerabilities there that they actually exploited to get root access in that process. Once they're root, that's basically where iPhone security faults out. So once they've done that, they download basically a file system, install it, and there's your jailbreak. If this seems like it's a perfect platform for a rootkit, well, now you know why I got into this. Because yeah, if you can basically follow the same process and load your own file system and do this to users without their knowledge, it's a pretty scary attack. I just want to point out too, the way that the whole thing was written was very, very professional. The exploit's really, really high quality. So again, very impressed by the work there. All right, so I started reversing this thing right after it came out. I suspected Comex might release the source, but we kind of wanted to get a jump on it. I also just love doing this stuff. I'm a big, I have OCD for binary reversing. I'm not necessarily even executable, but you put a strange hex dump that nobody recognizes in front of me, and I'll sit there and I'm obsessive. I'll sit there and figure out what it does. At least I like to. No, I don't always win, but I like to try. So again, like I said, while I mentioned that I wasn't sure if the source would come out, it did. Right after Apple released their patch, Comex released the source to the exploit. It's actually just as impressive in source form as it was in binary form. And when it came out, I had been doing this reversing. I immediately switched over to branching his project and just using the source because, I like to work smart. But I learned a lot of really cool stuff along the way about the exploit, about the iPhone. It was all new information to me. So I don't regret this. And I think it makes a pretty interesting talk. So that's why I'm here today. All right, so this is how I started the reversing, and bearing in mind that the source is out now, and you can kind of correlate some of the reversing information with the source, which is why I didn't cover the source as much in the talk. But it's interesting to see how they line up. So I started with this PDF. We knew that there was a blob of data in there somewhere that was exploiting a vulnerability, and I've been hearing rumors that it had to do with the fonts. So we found the section, and I'm going to go through step by step, but basically, started with PDF. We started comparing the different versions of the PDF. We saw that there was one chunk of data, which is this big zlib deflated blob of data that was different between them. We knew that was probably where the interesting stuff lived. And we zlib decompressed it, started looking at that file, and it was obviously some kind of here's a hex dump. You see Times Roman, it was okay, so I was like, yep, there's a font vulnerability. I did a little bit of research on the CFF on different font formats, and I'd heard some rumors about CFF with the free type thing, so I just verified that it had the characteristic header of a CFF file. But there were obviously other things going on there. This was a pretty standard exploit. The thing was, it was a really big blob of shell code. And I'm sorry, I picked the wrong color for those screens. So I'm sorry, you won't be able to see this, but this was basically the ARM assembly code for the exploit. I'm sorry that you can't see that very well. I don't know if I can modify the brightness, but anyway, this was the code that was used to actually find the code's location once it was in memory. And then basically, this was actually, I believe, they were doing something with ROP here. I'm not an expert on this, and I want to catch the next talk, which talks about ROP, return-oriented programming. But there's some of that going on here. This was the actual extract for the integer overflow vulnerability in IOKit, which I was actually really intrigued by, because this was a kernel-level privilege escalation vulnerability in OS X, or in the Darwin, iPhone Darwin. And you can kind of see there's some telltale signs of some integer overflow attack going on here. I had more information actually about how this worked out, but this was an interesting confirmation that this was an integer overflow. So inside of this file, I think I skipped over really quick, but there, inside of here, there were three big components. We identified the egg, which contained the CFF font, malform font, the shell code. Then there were two full-size dynamic libraries inside of it. We could actually identify them by the headers. So this is actually like, they'd made full use of the space they had available for the shell code. What would happen is that once they were in memory and had code in memory, they would load the library from the file system. I'm sorry, they would map the memory for the library and begin using it like any other dynamic library. And the entry point that they used for this dynamic library, which was the entry point for the actual installer, was this function. The nice thing about it was, this is a little hard to see, but this was actually all written in Objective-C. And there's some great tools out there for reverse engineering Objective-C. The way that Objective-C compiles, it leaves a lot of artifacts. It's not quite like decompiling a Java class, but you can get a very concise description. There's a tool called ClassDump that looks at the Mako header information for the Objective-C classes, and then or where the Objective-C class information is located in the binary. And there's a lot of information you can harvest from the structures. So it's a sort of like Objective-C, if you've never worked with it, it's sort of like a semi-dynamic language. All right. So once it was executing the shell code and this library, it would then download this file called the wad.bin, which contained the file system. It also contained another dynamic library, which was an installer for the file system. And we reversed the binary structure. This slide just kind of shows what the structure of that file was. I'm just going to move on here. I'm running out of time. All right, so I had enough information at this point to begin weaponizing, I thought. So I just went ahead and began reverse engineering the install UI.dilib dynamic library and the wad.bin. I wrote some tools to sort of automate some of this. Found out what I had to patch out with all those pop-ups. My objective was to get rid of anything that would tip off the user that this was happening to them. So I figured out, where I needed to patch out instructions, and the process was very similar to one you might use if you were cracking software. So, I used all the same tools, IDA. I used diff files for the patching. I actually ended up writing a new format for the diff because I needed some dynamic features. Again, sorry you can't really read it. But, all right, so also going into this, I didn't really know too much ARM assembly. I'd done some work with MIPS and x86. I like to think of like going into a new instruction set, kind of like visiting a new country or a new continent. This is my second time in South America. The first time I came here, I made sure I knew how to say a couple things. One beer, please. One more, and where's the bathroom? So when I got into ARM, I was like, well, there are just a couple things I need to know how to say in this land here, right? I need to know how to create a NOP, a no-op. I need to know how to deal with branch instructions and what they look like. So that when I patch the code, I can move around in it and pass over the stuff that I don't want to execute. And the point of this slide is really that you may be entering into some strange territory. It can be really intimidating, but if you tear it down to the bare essentials of what you really need to know, you can get a lot done. And sometimes it's good to take a step back and see what is it exactly, what's my objective, and what do I really need to do? I can learn the rest of it later. It's not like you would go to, I didn't go to when I came to South America first time, I didn't go and learn the language first, and I'm kind of an idiot for doing that. I'm sure there are people who are like ARM experts that think I'm an idiot for not teaching myself ARM. Similar to the people who in Ecuador, when I visited, thought I was an idiot for completely butchering their language. But I still managed to get there and back and get drunk and find the bathroom, so. All right, so I covered the diff file. I wrote a small, so part of the exploit was actually in the web service that they set up on jailbreakme.com. Actually, you had to identify different characteristics of the victim as they were connecting to the website. So they wrote some interesting JavaScript actually, which I was going to talk a little more about, but I didn't have as much time. So suffice to say that there was, they would identify the user agent and then use some JavaScript to take that user agent, which only gave them really the version of the iOS, but then they could use that to, the JavaScript would actually profile the client using a heavy process, and depending on how it performed and the number that came back from this long-running process for the time that it took, they could profile what the client was, which was actually pretty cool. I thought it was neat. And then, so my tool just does some on-the-fly assembly of the PDF. I think they pre-compiled all of theirs, and the reason for that was actually that there were several checks in there that, okay, I must have passed over that slide. There were several checks in the actual exploit that Comex had added to kind of limit it only to jailbreakme.com, and one of the things I had to patch out was those checks, along with all of those pop-ups. So that's part of what this tool does. And then I created my own wad.bin. So I was going to spend more time on the actual rootkit file system, but I wanted to make sure I could give you guys a demo. I got a little bit of time cut off of my presentation, so I just kind of narrowed it down. The reality is that it wasn't anything cutting edge. Honestly, I have not gotten into kernel rootkits yet. That might be the subject of more research in another talk. But it was nonetheless very interesting what I could just do with nothing more than a couple open source source packages from Cydia, a little bit of patching on some apps when I needed to, using a similar process that I used for patching the exploit. So I just created, this actually resembles to me like an old 1990s style rootkit. You patch out the userland programs like ls, find, ps, netstat, so that they don't necessarily report information. You create some kind of a backdoor that you can get to. I wrote a short UDP knock daemon, a port knocking daemon, that if you hit it and give it a special word, it'll open up a bind shell that you can then connect to, so that it's a little harder to notice that it's there from the network. And you have to know secret passphrase to get to it. It wasn't terribly sophisticated, but it was just a POC. And I also wrote some tools for doing some interesting things once you're on there, like recording from the mic, which is actually just a trivial app that uses the Audio Toolbox API on the phone itself, because this is something that you can write apps for the App Store with. And then there's a really cool VNC server that Sorik, who's the maintainer of Cydia and also the maintainer of a lot of the Cydia packages, wrote. And I had to patch out some features in there, and I worked a little bit with the code, and I actually ended up doing more of it with the binary, but just to disable it appearing in the UI. So yeah, it's just all user learn. I don't really have any excuses, but I kind of feel bad because the jailbreak guys are doing some crazy things with the kernel, but I'm still learning from them. So, like I said before, maybe future work. All right, so I have a little demo for you of my rootkitting process, which I called Prison Riot, for lack of a better name. Okay, that was good. So here I was just setting up my environment, just giving you some config information. I've got my IP address, the IP address of the victim. I just set it up on a small associated wireless network, ad hoc network. There's the IP address of the phone. The phone with its IP address, showing that is the guy. Then I'm going to go ahead and start up the Riot server, which was that web server that I told you about. That was actually written in Sinatra with Ruby. Really nice little quick framework. I just needed something quick, up and running. There's some static files, including the index page, the wad.bin, actual executable, and then these are the directories that it uses for assembling the parts of the PDF. And they're split out by, I don't know if you can see it, but they're split out by version of the iDevice and version of the OS. So when it gets a request for a PDF, which is generated by that index.html, you're going to see a pop-up here in JavaScript from that, just so I can kind of step through it. It knows to assemble a new PDF for that. And all it really has to do is patch in its own IP address so that you can use this on multiple hosts without having to go through a lot of stupid steps. So you can see there that the request is made. It hasn't actually launched the PDF yet, but once I say OK, it has. Now what's happening is that it's downloading the PDF, and you see immediately after that we have shell execution, or we have code execution, because it's now downloading the wad.bin, which was actually executed from that install UI.dilib. Also, you notice that the phone is completely usable. In fact, we're not even in Safari, but the Rootkit is actually in the process of being installed while we use our phone. I'm going to actually go back in a minute in this video back to Safari, and we can even still browse to other sites while this is going on. So it was a very, as I said before, this wasn't necessarily my work. I figured out how they did it, but they did a very nice job of putting together this exploit. It was, I think I had a slide that mentioned how polite it was. It even dropped its privileges back down to mobile when it's done. So very quality, high quality work there. Sorry, the video quality going through my laptop to that projector is not very good, but all right, so I can probably skip through this. It's just me messing with stuff. I know I'm running out of time, so. All right, so exploit has finished. The rootkit's installed. Phone's still usable. All right, I'm just going to go ahead. So then I put it down. And now we're going to go ahead and start accessing the backdoor that I installed. Here's that bind, or the knock daemon that I talked about. I set that up listening on UDP 9999. And connect to it, give it a really creative password. And it now has launched a bind shell listener, which when we connect to will give us a root shell. You'll see that in a minute. That one's listening on TCP on the same port number. Once we're in here, I'm going to look around a little bit on the system. We notice that I have access to the Unix system. I'm running as root, and there are a couple patch binaries to help hide these. The reason for the hiding this way was the vulnerability works just as well on a factory iPhone as on a jailbreak phone. So I can own people with this, or could have owned people with this before it was patched, whether they were jailbroken already or not. And if I owned somebody who was jailbroken, that was the purpose really of most of the rootkit, because you can't tell what's going on if you're an average iPhone user from the UI at all. All right, so another thing I installed was that VNC server, and this is just fun to see because I can literally control the screen, control all the hardware, control the camera, and the GPS. I can see where the victim is located. So we'll see in a second, I'm actually controlling the screen interactively, just like a VNC server you would install in the beginning. That's me typing actually into the phone and it being displayed over VNC. Hi, Ekoparty. Yeah. Hola, mucho gusto. All right, let me skip ahead. There's a little bit more, and I want to see if I can get to it. It's just mostly in the demo here. Try to cut it down, but there was just some fun stuff to show. All right, so here we go. I'm accessing the GPS. You can see actually now the screen is actually being literally controlled by me. And there's actually, now you know where I live. So that's my house. This is, I actually took this video here, but I didn't have a SIM in here, so it registered my old location at home. So, let's see what else. So yeah, I can control the phone, make calls, and if I wanted to, I could probably, I had been capturing the mic audio. I could probably forward audio as well, to make a little bit more work, but you have access to all the hardware on the device, so there's nothing stopping you from actually routing calls from someone's phone, or for that matter, monitoring them remotely. All right, so yeah, here's me playing with the camera. I can access the camera, take photos. I guess this is kind of boring because you probably just get the pictures of the inside of somebody's pocket most of the time, but I thought it was kind of cool. All right, there's my face, handsome fella right there, and there's my computer. All right, and there we go, that's it. So I just had a couple more slides to get back to, and we'll wrap this up. I just had a couple thoughts about, I wanted to share as I was thinking about this, mostly about, you make money off of it. Whether that's evil or good is irrelevant. The point is that you as the user, I advise you to take control over your technology. Once you've jailbroken it, treat it like any other computer. Make sure you're staying up to date on patches and aware of new vulnerabilities as they come out. Strip services. Don't run stuff you don't need. You can actually download VNC from the App Store and leave it running, which would be probably a really stupid thing to do. And you know, I think we're going to start to see, as more of this malware starts to come out, we're going to start to see more defenseware, hopefully, coming out. And I have a feeling the most powerful incarnations of this initially, before Apple really jumps on the bandwagon, are going to be in the open source space, of course. So that's all I have. I'll be around if you have any questions. I know I don't have a lot of time left, so I want to thank you. Also, I'm going to be releasing code in bits and pieces, probably starting with the patches that I made to Star out on GitHub. There's my address on GitHub. Feel free to follow me. Feel free to branch. My code is actually going to be a branch of Fomex's. He's got his code up there too. So you'll be able to go back and see the original source if you're interested as well. All right, thank you. That's all I got.